Hey everyone, this is lesson 913 on graphing form of a quadratic function. Prior to this lesson, we introduced the graphing form. So today we're going to go over the graphing form in a little bit more detail. I know last time it was more of kind of investigating and kind of building up to the form. So now I'm going to talk more specifically about it and how to use it. Reminder of some of the other forms that we talked about before. We have our standard form, which we will talk a little bit about today. Factor form is also useful. I mentioned to find x-intercepts. So definitely that'll end up coming back. We'll be utilizing that. And then graphing form is what we're going to be talking more specifically in these notes again. I also mentioned in our last notes about the different parts of a parabola. I just put it here so you have a reminder. This is still what we're talking about. You still need to know the different parts. So if you, it's up to you if you want to copy that down again, or if you have it in your previous page of notes, then that should be fine. And then from the handout that we talked about last time, these are the specifics that I kind of went over at the end of the handout when we finally got to the actual graphing form, and I went into specifics of what the A value helps us with, what the H value, K value, and vertex. So specifically, I'm going to go over these values again, more so focused on our A value, which is the letter in front, and our vertex. So vertex is made up of our H and our K. So let's jump into our review of this. So here's another reminder of what our graphing form looks like. Sometimes it also goes by another name called the vertex form. The main reason being that this form immediately gives us the vertex of our parabola, which can also be called or is referred to as a locator point. When we talk about different functions, that'll be very similar to this. More commonly, we'll use locator point, but on a parabola, we'll be more specific and call it a vertex. Kind of like with quadrilaterals. Quadrilateral is a general name, but then there's more specific names for like the other quadrilaterals, like square, rectangle. So it's kind of like that idea. So I mentioned the A value. So the A value is key to us because it tells us two pieces of information. And so the first thing we look for is this A value positive or is it negative? So if there's no plus sign in front, then we assume it's positive. If there's a negative sign in front, then we know it's a negative orientation. So if it's negative orientation, means it's going to look like it's upside down, like a frown. And if it's positive, it's going to be smiling because maybe it has a positive attitude, you're going to smile. Negative attitude, you might be frowning all the time. All right, so the nice part is all we need to see is this a plus or is this a minus in front? Now the other thing is the actual value of our A. So in this case, we're actually looking at the absolute value of A. So means we don't really care if it's negative, we just care about the positive component of our A value. So if it is a big A value, like for example, if I put, let's say if I say this is a 4 in front, then that means it's going to be stretched vertically a lot. So it's going to look skinny. If I go smaller, if I do maybe like 1/4 instead, then that's a fraction. It's going to look wider. So the number in front, this A value, will give you an idea of the shape of your parabola. Is it going to look skinny? Is it going to look wide? Um, and that's based on the stretch factor. So, and for the most part, I mentioned a couple of ways of describing stretch factor. Um, it's stretched vertically or stretched horizontally, or we use the word compressed. So for the most part, let's just assume this stretch factor is stretched vertically. So that means always going to be stretched up and down. So if the stretch factor, if I talk about stretch factor, let's just assume we're talking about vertical stretch factor. So, all right. And now the H and K values, we talked about this before. The shift, H will shift left or right, and your K value will go shift up or down. Right. So that's one thing. You need to know the specifics of that. But more importantly, I think what's helpful is just knowing that your H and K value will give you your vertex. All right, so this is another point on the graph. This is not the same as our X and Y values. These are two other values that are going to tell us exactly where our parabola is going to be located. So this will tell us where it's been shifted to. So if we know the vertex, then we should know where it's been shifted. Left, right, up, or down. All right. Let's look at an example with actual numbers. So first I'll just show it like this. Let's see. So here's our general form, and I've written an example with numbers. You can see the format is pretty much identical. The only difference is I've inserted some numbers instead of the letters, right? But we still keep the X and Y. All right, so what we're going to do, what I want us to be able to do, is to be able to look at an equation like this and be able to graph it, really, and be able to describe it, and can you tell me anything about this graph? So I think we know enough. I think we could find out enough information that'll help us graph this. So let's look at, hopefully you have this part in your notes. Because as I go on, I won't have it on the screen, so it's going to be nice for you to have it right in front of you. So if you haven't copied that down yet, I would say pause it right now so you could make sure you have that as a reference. All right, so in our example, what I want us to be able to do is identify a few things. Now, this is just the beginning of certain aspects of the parabola that I want us to be able to identify. Other things that are not on this list would be x-intercepts, y-intercepts. That's something else. Those are other details that we should also be able to find out as well. But I want to keep it a little bit simple, and let's just focus on some of the basics. All right, so what I want to know is, first thing is, what is the orientation of this graph or this parabola? So just by looking, well, the reality is, the reality is you could always put that in a graphing calculator and you could just look at the graph, right? But that, to me, honestly, is 10 times more work than just looking at the equation. So when I want to find out what the orientation is, we are going to look at our A value. And the A value is going to be right in front. So is this, my question to you, is the orientation of this parabola going to be positive or is it going to be negative? So let's see if you could tell me that. All right, so if you said positive, you would be correct, right? So it has positive orientation, which means it's going to look something like a U-shaped. Right? I put a little parabola there as a reminder of what it's going to look like. Stretch factor is going to tell us whether it's skinny or wide. So what is the stretch factor of this parabola? So let's see if you can tell me what the stretch factor is. I'm giving you a hint, I'm looking for a number. All right, if you said 2, you would be correct. And the reality is we're looking at the absolute value of 2, which still is 2. So our stretch factor is 2, which also means what I do know is this is going to be a skinny, if I could draw a skinny parabola. You don't need to draw those. I'm just drawing it as a reminder for us. Vertex, I want to know where this graph is located. So the nice part about a parabola is if you move the vertex, all the other points move with it. So it doesn't get distorted. So as long as you move the locator point, the vertex, the whole parabola is going to move with it. So I want to know where our parabola is. This is going to be, vertex is always going to be a coordinate. So we're looking for our h and k. So as a reminder, I'm going to put this is our h and this is our k. All right, so our h value, my question to you is what is h? Where is our h in this equation? Let's see. I'm going to see if you could get this correct. I'll be honest, most people will get this one wrong. And let's see if you're able to get this. So h is, okay, if you said h is 1, you are correct. If you said -1, that would be probably the most common incorrect answer. And I'll discuss that in a second. And then for us, our k value, in this case, our k value is going to be 3. All right, so let's look at sketching a graph of this. Now, I'm saying sketch here instead of graph because I don't want us necessarily to have to plot tons of accurate points, but we do have at least one accurate point and we have an idea of what it should look like. So let's just sketch a generic picture so that we get a good idea of what this graph should look like. So we would start with the vertex. So the vertex is here. So let's look to see where we would plot this. We'll start with 1, 3. So 1 is going to be on the x-axis. Let me label these. So this is going to be 1. This is 1, 2, 3. I didn't even label these. 2, 3. All right, so etc. So that means my point is going to be at 1 on the x-axis and up on the y-axis. So this is 1, 3. So this is where our graph is going to be located, our parabola is going to be located. So this is a positive orientation. So that means it's going to look like a smiley face. So then this vertex is the bottom, right? So this 1, 3 is the bottom of our parabola. And it's going to have a stretch factor of 2, so it should look very skinny. So I think I have a good idea what that should look like. So normally I would start by, I'll be honest, normally I start, if its stretch factor was 1, I would always start with points like this. Like that's always the case. A parabola always looks like that. But it's supposed to look skinnier than that. So that means I'm going to do, instead of up 1 over 1, I'm going to go up, let's use a different color, up 1 over, or up 1 over 1, up 2. All right, so twice as high. So then when we sketch a picture of this, let me use a different color. Let's use, all right, so it should look like a skinny graph. This looks ugly. So let me see if I can do a better job. That looks worse. All right, maybe you could do a better job than I can. All right, that's good enough. All right, so this would be what our parabola looks like. So if you wanted real points, even if you're asking, well, how did you get those points? You could just plug in numbers. So if you plug in a 2 into this equation, meaning if I replace this x with a 2 and I do the calculations, it should give me a y value. If I plug in a 0, if I plug in 0 to here, then it'll give me another point up here. So that's an easy way to get a couple points, and then you have a pretty decent sketch. So when I talked about earlier the what do you call it? The vertex. If I move the vertex, normally it would have been down at the origin, right? It would have been down at the origin, but it's been shifted. So the h value says it was shifted to the right one, and it was shifted up 3. So I'm going to shift it up 3. All right, so that's what's happening with the vertex. That's what's happening with the parabola. Now, to address the issue with, for those of you that said h was actually equal to -1, which is, it's like the best wrong answer you could give. Let me explain why. So the general formula, right? The general formula, if I go back for a second, says x minus h. So this minus is already part of the equation. So when I look at this equation, I notice that this minus is already part of the original formula or original equation. So when I'm looking for my h value, really what I'm looking for is, just the number. Now, if in the event, if this happened to be y equals 2 times x plus 1 squared, then our h value, keep in mind our h value was supposed to have a minus in it, but instead it has a plus. So that must mean that our h value here, h value must be -1. All right, so an easy way that most people remember this is whatever you see here, your h value is always the opposite. So if you see a -1, your h value is +1. If you happen to see a +1, then that means your h value is, h would be -1. So keep that in mind. Let's see, I think I have some examples of that coming up. So we'll see that in the next problem. Maybe it'll make more sense the more we do. All right, so here, let's try to do the same thing. I have 2 equations set up for us, and then we'll do the exact same thing. We want to be able to identify key parts of the graph so we could do a nice sketch. And the nice part is you technically don't need a graphing calculator to graph these. So let's start with the first one. Y equals to negative 3 times x plus 2 squared plus 1. What is the orientation of this parabola? All right, if you said negative, you would be correct, right? It's a negative orientation, which means it should look like a frown. It's going to look upside down. Stretch factor, again, stretch factor, we're going to look at our A value. So just right now to find the orientation, I'm only looking at the number in front. So in this case, we had a negative 3, which told us it was negative orientation. Stretch factor is actually equal to, I'm going to write this as absolute value of negative 3, which equals to 3. Right? I really don't care about the negative. I'm only concerned about positive stretch factor. Like we've seen stretch factor before or scale factor before with other shapes. If you think about it, every time we see a scale factor, even if something's getting bigger or smaller, the numbers were always positive, right? So if something's either twice as big or it's half as big, we would never say something is negative 2 times as big or small. So stretch factor should always be a positive number. So that is also going to be super skinny because of the 3. Our vertex, let's see if you could get this one. Pay attention to, we're looking for our H and K. I'll give you a hint of where we're looking. We're looking inside these parentheses, and we're looking at the end. So let's see if you can get this correct based off of what I just talked about on the previous problem. What is the vertex? What is the vertex of this parabola? And I'll give you another hint, or the one tricky part. We're trying to decide: is this going to be a plus? Is H going to be a +2, or is H going to be a -2? Think about what I said on the previous problem. So, what is the vertex? All right, let's see if you got this correct. If you said the vertex is, so let me change the color. So our H value is going to be -2, and our K value is going to be +1. All right, so with the H value, like I said earlier, it's always the opposite of what you see. So if it says +2 means your H value is -2. That's the only one that's really the opposite. Your K value is going to stay the same. So if I happen to put a -1 here, then our K value would have been a -1. So something to think about. All right, so then we could do a nice sketch of that. We would plot these points. So -2 is on our x-axis. So we're going to go to, let's see, this is -1, or I should do it underneath. So this is -1, -2, -3, in case you need numbers to guide you. Oops, -2. All right, so I'm going to be plotting a point at -2. I need to go -2 and +1. So we're going to go up 1. So I'm plotting a point right here. All right, so this is going to be our vertex. So this is at -2, 1. And there's limited room here because I already knew this was going to be negative. It was going to be upside down. So now our graph's going to be facing downward. So let me I'm going to start with, you could plug in some numbers if you'd like. You could plug in maybe a -1. So this kind of answers the question before on the previous handout we did, like how do you know which numbers to plug in? Well, once you know where your vertex is, our vertex is around this point, so then you know you want to most likely plug in numbers to the left and to the right. And that's going to give you other points in this area. So this is a sketch, so it doesn't necessarily have to be super accurate, but it should resemble all the descriptive characteristics we've mentioned. So it should have negative orientation, so we need to make sure it's upside down. And the stretch factor is 3, so it needs to look like it's been made skinny. And the vertex needs to be in the right place. So this looks like a skinny parabola, and it's upside down, so it resembles the graph that we're looking for. All right. On this next one, we are, if you notice, it looks a little bit different than what we just finished working with, the last two examples. And then usually when students see an equation like this, we get so used to doing equations that have a lot going on, and it becomes easier, that when we see stuff that's missing, looks like it's missing information, students tend to get more confused, when in reality this is actually a lot easier. So let me kind of describe some common mistakes that happen here. So I am looking for the orientation, right, as usual. But when I do, I'm looking in front for the A value. Now, if you notice, it appears that there's no number here, right? So this is one of those simple things you just need to remember, that sometimes there's an invisible 1, right? So it's like 1 times all this, which means it's not really going to change. So there's an invisible 1 here. And I know it's not a -1, because if it was a -1, then I would see the negative. But when it's a +1, it becomes invisible. So for the most part, let me see if I could draw in a light, too light. All right, so there's a 1 there, if you could kind of see that. I've tried to use a lighter color. And so now I could answer the question about the orientation. And so the orientation is going to be, it looks positive, right? That 1 is positive. And then stretch factor, well, that's that same 1 that was missing, or looked like it was missing. So that means whenever there's a stretch factor of 1, means it's not going to look skinny, or it's not going to look wide. It's going to look like the default parabola that we're used to. That doesn't mean it's not being moved. We still need to look for the vertex, so our H and K values. So when I look for my H value, I'm going to be looking right here. And so it says -4, which now I'm remembering, it's always the opposite of what it shows me. So if it says -4, that must mean my H value is +4. But when I look for my K value, the K value, which is normally at the end, right, like at this +1 on that first one, there isn't anything there. Now, that 1 is usually being added, so that means what would be here, if we did add a number, what could we add so it wouldn't change the equation? And the only thing we could add is a 0. So the reality is your K value is equal to 0. All right, so that one's could be a little bit tricky. So that means my vertex is at 4, 0. So there's really like a plus 0 here. All right, now we have an idea where our vertex is at, and we can plot that point. So we're at 4, 0. 1, 2, 3, 4, 0. This is 4, 0. All right, so that means our vertex, this is the first one we've seen where it's actually on the x-axis. It is positive, so that means we're going to have, and it shouldn't be stretched, so it's going to be normal. So normally, like I said earlier, if I just go up 1 over 1 in both directions, that's a good start of where the parabola should look. And then I happen to know what the pattern of points. They're always the same and never changes. So up over 1, up 1, or over 2, up 4. It's the same pattern of points every single time with a stretch factor of 1. So this should be fairly easy to graph. If you graph enough of them, you should notice it's the same picture every time. All right, so it should look something like this. And those will keep going up and up forever, and it'll be getting wider forever. All right, so this is an idea of what you should be able to do. Notice no graphing calculator. The extra points, you might need to plug in some points. Maybe you would use a calculator for that if you can't do it in your head. But for the most part, be careful here. If on your paper right now, if you're sketching this graph and yours happens to look, let's say, like this, that would be wrong. Right? Even though it says sketch, if I saw that graph, I would say, nope, clearly that is too skinny. If your graph looks something like this, where it looks like you started off good and all of a sudden you just stop caring at the end, then I would probably take off points for that. Same thing if you said like, oh, okay, it looks like that. Or here's another bad example. If yours just looks like this, it's super short and tiny. I know probably some of you have that on your graph right now. I would take off points because I don't know if you think it stops there or if it goes up or if it goes wider. So you need to give me something more to kind of give me a really good idea of what you understand about the graph. Like I said, you could always put that in a graphing calculator to actually see what it looks like. Use Desmos.com. I would strongly recommend using that one. That'll give you a good picture of what the graph should look like. All right. And so it's nice we could graph things a little bit easier, but graphing form is not always what's given to us. So sometimes it's in standard form. So this is an issue because we can't just take an equation that's given to us like this and say, okay, let's figure out the orientation, let's figure out the stretch factor, let's find the vertex. It's not given to us in the right form, so then we would have to do some use some other approach to finding that information. So we could factor this. We could try to factor it and see if we could figure out x-intercepts and go from there. So it's not impossible, but it's a lot more algebra work. But luckily, we could use completing the square to write it in graphing form. So this is something else we learned earlier in the year, was how to complete the square. So I'm not going to go over the specifics of how to do that too much, but I'm just going to remind you of a couple of steps so that we could get to the part where we could actually graph this. All right, so if you are given an equation in standard form, it should look most likely something like this. So our first step, if we're going to do completing the square, really is to think about how to complete the square. So what I've done here is I've kind of written it out with the expectation of I'm going to be adding and subtracting the same number. I need to add and subtract the same number so that it doesn't affect the equation. So if I add 1 and subtract 1, they cancel each other out. If I add 5 and subtract 5, they cancel each other out. So I need to make sure I'm adding and subtracting the same number. I've also included parentheses. You can or cannot include it, but I did it because I'm really focused on trying to complete this square. So remember when we talked about actually drawing out like algebra tiles. You'll also notice this +1 is still there, and I just pushed it to the side. So this is kind of the general format you would follow if you're trying to still do completing the square. So if you remember the shortcut for this was if you take 6 and divide it by 2 and square it, right? 6 divided by 2 and square it, that's going to give us, well, 6 divided by 2 is 3, and 3 squared is going to give us 9. So the magic number for us is going to be 9. So we're going to add 9 and we're going to subtract 9 in this equation. All right, so the reason why we did that was to complete the square. And so once it's a perfect square, I could actually write it as a perfect square. So this factors nicely to x plus 3 squared. All right, if you remember when we did this before. Again, if you need review on completing the square, you might want to look back at those notes or ask me about that in class. All right, so the rest of this is -9. So we're looking at -9 plus 1. That's still on at the end of that equation. So -9 plus 1 leaves us with -8. All right, so now, if you didn't notice, now we have an equation. Now we have an equation in graphing form. So now we should be able to identify the parts easily. So orientation is going to be positive, right? Because there's a positive, there's no number in front, which means there's that invisible 1. Stretch factor is also going to be 1, right? Because I just said there's a 1 in front. Vertex, let's see if you could tell me what the vertex is on this one. All right, let's see if you got this correct. So this is going to be -3, -8. All right, if you got that correct, good job. It's always the opposite of what you see inside. So that's why it's a -3. And then the K value is always what you see. So that's why it's a -8. All right, so that's enough for us to plot. So I'm going to plot this vertex. So I'm going to go to -3, and this actually goes down 1, 2, 3, 4, 5, 6, 7. Wow, I don't even know if I have enough room. -8. So this is going to be -3, -8. This is way down here. That's pretty low. So this is our vertex, right? This is our vertex. And I said this was positive, so it is going up. So we should have a point here and here. Scale factor was 1. So I happen to know these points. We are looking for a sketch. So it should, there's a lot more points we could easily do. But for the most part, oops, that looks ugly. All right, so I'll stop there on this one, but we would probably want to see where does it cross the x-axis, and maybe where does it cross the y-axis. So those would be some other points we would probably look at. All right, so I know this. I want to wrap this up. there's a lot of different ways you might see some parabolas written. Here are some 4 that I didn't really go over because we would have a lot more examples. But I kind of just want to talk about them really quickly. So this first one, you'll notice I have a half here, right? So things to pay attention to. This would have a negative orientation, right? Because it has a negative in front. And the scale factor would be 1/2, right? So it's okay to have a fraction as a scale factor. That means this graph is going to look wide. So that means not only is it going to be negative, but it's going to look like a wide parabola. Right, so right away I know what that looks like. And this is going to be at 3, 0. Right, so just by looking at this equation, this is what I know about the graph. I know where it's located. I know it's going to look upside down. I know it's going to look wide. Everything based on these numbers. All right, also on the second one, when I look at the second one, we didn't really talk too much about these, but we did it on the previous lesson. In the previous lesson, we did have an example like this. So if I asked you for maybe the A value or the orientation, we would still be looking for the number in front, which in this case is still 1. But when I want to know the vertex, if I'm actually looking for the vertex on this one, you'll notice a couple things that it doesn't look like this format, right? Where we have x minus some number and then the squared on the parentheses. So here it's just x squared, which it's really saying, let me rewrite this. This is really the same thing as x minus 0 squared minus 4. So there's a 0 there that we don't see because it's not needed, which means our vertex ends up being at 0, -4. All right, that's different than this other equation right next to it, where you notice that -4 is actually in the parentheses. So in this case, our vertex, if we wanted our vertex on this one, so this would be actually 4, right? Because the -4 really means 4. And what's our K value? Well, the K value is missing. We saw this earlier. If the K value is missing, then that means this is a 0. All right, so note the difference on how these are written and how that impacted the vertex. All right, and then the last one, we're going really back to where this all began, was our default parabola, y equals x squared. So a lot of times people will get very comfortable with all these other complicated ones. And then as soon as I give them a graph like this, I've literally had this on a test where a lot of students, they just don't know what to do. They're like, I have no idea what that one is. There's no A value, there's no H, there's no K, I don't know what to do. So remember, this is the default one, which really means this is the same thing as, let me rewrite this for us. Imagine it looks like this. X minus 0 squared plus 0. This is the same thing. Now, instead of having to write it out like this with a bunch of zeros and ones, you could simplify it to y equals x squared, which means we already know the stretch factor is going to be 1. Scale factors, stretch factor is going to be 1. It's positive, and our vertex is at 0, 0. All right, so I'm going over these kind of quick, but I wanted to make sure I covered these because you will see a variety of equations given to you in graphing form. So I'm going to stop there. Let me know if you have any questions, and we'll see you next time.